In today's lesson, we're going to be talking about dividing and multiplying radicals. Our first problem is the square root of a to the ninth all over the square root of b to the fifth. Now, one important rule to remember when dividing radicals is that you can never have a radical in the denominator. So remember, the denominator is the bottom part of our fraction. So let's first start off by looking at our square root of a to the ninth. We want to see if we can simplify that at all. And we can. We can simplify it down and see how many times 2 can go into 9. We pick 2 because remember, in the front of every square root, there's that 2 there. So we would take 9 divided by 2, which would give us at least a to the fourth going in. 2 times 4 is 8, so we would have the square root of 1a left over, a to the first power. So a to the ninth, the square root of a to the ninth, can be simplified a to the fourth square roots of a. We do the same thing on the bottom. That 2 is out front of the square root again, and so we can simplify the square root of b to the fifth down to b squared square root of b. I can do this because when I take 5 divided by 2, I at least get 2, the b squared. 2 times 2 is 4, so I know I have 5 minus 4, so I have 1b left over underneath the radical. Now, I'm still not done because I still have a radical down in the denominator. So, my next step is to multiply by what I need to get rid of it. In this case, to get rid of the square root of b, I want to multiply both the top and bottom by the square root of b. Doing this, I get a to the fourth, and when I combine those two, I get the square root of a times b. All over, I have my b squared still. Taking the square root of b times the square root of b, I get the square root of b squared. Once again, I can't simplify anything more on the top, so I have a to the fourth times the square root of ab, all over my b squared, and I can simplify the square root of b squared down to just b. And that's what I was looking for, so I could get rid of the radical. So, my answer would be a to the fourth times the square root of ab all over b cubed. And that would be my answer. This problem gets to be a little bit trickier when we want to solve it. So we want to be able to divide these and simplify it. My first step is to apply the fifth root to each individual piece. So I have the fifth root of 3 and the fifth root of 4y. My next step, I want to see if I can simplify it all. And I can't. I can't simplify the fifth root of 3 at all. And I can't simplify the fifth root of 4y. So my next step is to multiply by something on the bottom so I can get rid of the radical on the bottom. I have the fifth root of 4y, so I know I'm going to have to multiply by the fifth root of something. I want to be able to get completely rid of my fifth root of 4. So let's look at some possibilities of what I could multiply 4 by that could take a perfect fifth root. So let's look at some of those. 1 to the fifth power is 1. Well, I can't multiply 4 by anything right now that would give me 1. That would be easy. So let's continue. 2 to the fifth power is 32. Is there anything I can multiply by 4 to get 32? Well, there is. I can multiply 8 times 4 to give me 32. So that would give me a perfect fifth root. I want to do the same thing for the y. Right now, I have a single y under the fifth root, and I want to be able to get rid of it altogether. So the lowest term I can put in there to get rid of the fifth root would be y to the fourth. Because remember, when you multiply variables, you add like exponents. So on the bottom and top, I need to multiply both by the fifth root of 8y to the fourth. So let's simplify this. On the top, I have the fifth root of, combining everything, 3 times 8 is 24, y to the fourth. On the bottom, I have the fifth root of 8 times 4 is 32, which is what I know because I was planning on that. And then I have y times y, and you add exponents, so I would have y to the fifth. Continuing to simplify it down, on the top I would still have the fifth root of 24 y to the fourth, because that can't be simplified anymore. And then the fifth root of 32 I know is 2. And the fifth root of y to the fifth, we know there's a 5 out here, so we can divide our exponent of 5 by 5, which leaves us with just y to the first power. So my answer would be the fifth root of 24y to the fourth all over 2y. This problem deals with multiplication. So what we're going to be working on now is foiling or double distributing these two terms. So my first step is to multiply the first two terms. I have 7 square roots of 2 times 7 square roots of 2. Well, that is 49. I take 7 times 7. And then under the square root, I have 2 times 2, which is 4. And then I continue on. I would take negative 3 square roots of 3 times 7 square roots of 2. This would leave me with a negative. 3 times 7 is 21. And under the square root, I would have 3 times 2, which is 6. Again, I would take 7 square roots of 2 times 3 square roots of 3, leaving me with 7 times 3, which is a positive 21. And under the radical, I would have 3 times 2, which is just 6. And then my last terms, negative 3 square roots of 3 times 3 square roots of 3, which would leave me with a negative 9. Square roots of 3 times 3 is 9. Now that I have it all FOILed out or double distributed, I can combine like terms and cancel. Well, my negative 21 square roots of 6 and my positive 21 square roots of 6 can cancel. And I'm left with my 49. The square root of 4 is just 2, so I can multiply it by 2. Minus, I have my 9. And then I have my square root of 9, which can be reduced to just 3. The square root of 9 is 3. Continuing to simplify a little bit more, 49 times 2 is 98, minus 9 times 3, which is 27. 98 minus 27 is 71. So in this case, my answer came out to be perfect, a perfect number of 71. Again, for this problem, we want to double distribute or FOIL. So let's look at our first terms. We want to multiply those. 6 times 2 is 12. And then we have the square root. 3 times 5 is 15. My next term, negative 5 times 2 square roots of 5. Negative 5 times 2 is negative 10. And I have the square root of 5. And then the next one would be 6 square roots of 3 times 4 square roots of 2. 6 times 4 is positive 24. And the square root of 3 times the square root of 2 would give me the square root of 6. And then the last term would be negative 5 times 4 square roots of 2. Negative 5 times 4 is negative 20. And then I just have the square root of 2. Looking at all these terms, I want to see if I can simplify any more. Remember, you can't add or subtract any type of radical unless they have the same number underneath the radical. In this case, none of them are the same, and we can't reduce any of the radicals, so this would be our final answer. This last problem, once again, we want to simplify. There is a radical in the denominator, so it is not simplified already. To do this type of problem, we want to multiply both the top and bottom by the conjugate. The conjugate in this case would be the square root of 5 plus 1. So we would have that on the top and bottom. So when we distribute this out, we have 2 times the square root of 5 plus 1. And then on the bottom, we would have the square root of 5 times the square root of 5, which is the square root of 5 squared. And then we would have minus the square root of 5, 1 times the square root of 5. Then we would have 1 plus 1 times the square root of 5, positive. And then our last term would be negative 1 times 1, which gives us a negative 1 squared. Simplifying this down, we can distribute the 2 to both pieces. So we get 2 square roots of 5 plus 2 on the top, or in the numerator. The square root of 5 squared cancels, and we are left with just a simple 5. My minus square root of 5 and my plus square root of 5 cancel, go down to 0. And then 1 squared is 1, so I would have 5 minus 1 down in the denominator. I can simplify it one more step to get 2 square roots of 5 plus 2 all over 5 minus 1, which is 4. And that would be my answer to find the conjugate. I know it is my answer because the radical is out of the denominator.